Greetings to everyone. I am K. Sai Tanusha from CSCF section bearing roll number of 5A. Today my topic is about finite automata and their applications. Now let us discuss about finite automata and their applications. Introduction to finite automata. They are abstract computational models used to recognize patterns in formal languages. These are the foundational in the field of automata theory and formal language theory. What are finite automata? The finite automata are mathematical models which have states, transitions and inputs as shown in the figure. They process input strings to determine if they belong to a specific language. They are deterministic or non-deterministic based on how they handle multiple possible transitions. There are various components of finite automata as shown in the figure. We have the start state, transition states and the final state. They also have the self loops according to the given requirements. An input alphabet, which is a finite set of symbols that describe the state changes based on input symbols. There are types of finite automata, DFA and NFA. Both are deterministic and non-deterministic. You can have multiple transitions for a symbol or epsilon modes. Both of them are equivalent in terms of languages they can recognize. When we compare them, both of them have unique computation path for given input, ensuring deterministic processing, while NFS can have multiple paths which make them more flexible to design. Any of them can be converted into an equivalent using subset construction method. The formal definition of DFA it has 5 tuple consisting states: alphabet, transition function, start state and accept state. As given in the figure, we can see the self loops and the movement during the process. They map a state and input symbol to a single next state. Acceptance of input strings depends on ending in an accepting state after processing all symbols. Formal definition of NFA. An NFA is also a 5 tuple with states, alphabet, transition function, start state and accept states. They can map state and input to multiple states including epsilon transitions. An input is accepted if there exists at least one path leading to an accept state. The recognized languages can be shown as regular languages with a simplest class of formal languages. They are used in defined patterns for text processing, lexical analysis and more. Any regular language can be recognized by finite automata, DFA or NFA. While applications can be seen, they are used in pattern matching algorithms like regex matching. They enable efficient lexical analysis in the programming language compilers. We can see furthermore in the next things. Application in compiler design. Their phase are used to tokenize source code during the lexical analysis. They help to identify the keywords, identifiers, literals and operators efficiently. Now we can understand how it moves from initial state to final state through different transitions and movements. Network protocols and finite automata. The phase model the states and transitions of network protocols for communication from 0 to 3 as given acceptors, classifiers, sequencers and transducers. They assist in verifying protocol correctness and detecting protocol violations. Automata are used in designing reliable data transmission systems. Pattern recognition and search algorithms. Finite automata forms the basis of algorithms for pattern matching in strings. They are used in tools like grep and other text processing utilities. Automata improves the efficiency of searching large data sets for specific patterns. Digital circuit design. They are used as fundamental in designing sequential logic circuits which help to define the regular expressions with DFA and NFAs. They model the behavior of automata based hardware components like flip-flops. Automata helps in designing controllers and state machines in digital systems. Formal verification and model checking. They are used to verify system correctness against the specifications. Basic checking procedure and modeling checking with targeted abstraction is given in the both models. Automata based methods improve software reliability and bug detection. While it has some limitations, the FAs cannot recognize the context sensitive or context free languages. They are limited to regular languages which do not capture nested or recursive structures. More powerful models like pushdown automata are needed for complex language recognition. Future directions and reaches to the research where it continues to evolve with applications in machine learning and AI. Researchers explore automata based models for complex system verification. It helps to improve the efficiency, scalability in computational applications. Finally, we can conclude that the finite automata are powerful tools with diverse applications across the computer science. As we can see the total process through the states, and they are very useful with simplicity and most efficient during the compiler design, and which make them integral to many technologies and systems. Ongoing research expands their capabilities, impacting future innovations in computing. Thank you.